The journey of sugar begins here in vast plantations, where millions of tons of cane are harvested annually. Advanced mechanical harvesters work around the clock, processing hundreds of tons per hour with precision. The billets are immediately transferred to transport trailers to maintain freshness and sucrose levels. A constant stream of transport ensures the refinery operates at its peak capacity of thousands of tons per day. Every load is meticulously weighed and catalogued for yield calculation. A core sample is extracted to determine the sucrose content and purity of the batch. We enter the heart of the intake system, where the high-low unloader handles the massive scale of incoming raw material. Hydraulic systems exert enormous force to tip the trailers, initiating the flow of material. Thousands of tons of raw cane pour into the system every hour, forming the base of the production line. Sophisticated conveyor networks transport the material through the initial cleaning and sorting stages. Powerful magnets remove tramp iron, protecting sensitive downstream machinery from damage. The material now enters the preparation phase, where it will be cleaned and shredded to release its valuable juice to maximize purity. High-pressure air removes organic field trash before water is introduced. A final wet wash ensures that no field contaminants enter the extraction phase. Excess moisture is removed as the material moves toward the shredding units. A secondary magnetic trap ensures the removal of even the smallest metallic contaminants before the material reaches the high-speed knives. Advanced optical sensors identify non-cane impurities that bypassed initial cleaning. Precise pneumatic ejectors remove identified impurities in milliseconds, maintaining a continuous flow of clean material. Leveling knives rotate at high speeds to flatten the cane, preparing it for a uniform intake into the shredders. These serrated blades are engineered to withstand extreme impact while maintaining a surgical edge for hours of operation. The cane enters the hammer mill, the most powerful machine in the prep line, where it is shredded into fibrous wool. Impact at high velocity ruptures the plant cells, exposing the sugar-rich juice within the fibrous structure. What was once solid cane is now a homogeneous fibrous material, ready for juice extraction. Flow rates are monitored in real time, ensuring the milling train receives a consistent volume of material. The heart of the refinery, a series of giant mills that will exert thousands of tons of pressure to squeeze out every drop of juice. Thousands of tons of hydraulic pressure are applied, effectively separating the sucrose-rich liquid from the plant fiber. This first extraction, known as first express juice, contains the highest concentration of sugar. Sophisticated hydraulic systems maintain constant pressure on the rollers, adapting to the volume of cane in real time. Hot water is sprayed onto the fiber to dilute and extract any remaining sugar trapped within the plant structure. The saturated bagasse will be pressed again and again through a sequence of 5 or 6 mills to ensure maximum efficiency. Vertical chutes use gravity to maintain a constant high-pressure feed into the subsequent milling stages. Powerful pumps move the extracted juice through a countercurrent system, maximizing efficiency while recycling water. Self-cleaning scrapers prevent material buildup, allowing the mills to operate continuously for months during the harvest season. After 5 stages of crushing, the remaining fiber, now called bagasse, is nearly dry and depleted of sugar. Nothing is wasted. This fiber will be used as carbon-neutral fuel to power the entire refinery. The thermal energy generated here produces the high-pressure steam required for the upcoming evaporation and crystallization stages. The treatment phase begins with primary filtration to remove fine fibers and solid particles from the raw juice. Secondary rotary filters ensure the juice is free of microscopic impurities before chemical treatment. Sulfitation is the first chemical step, decolorizing the juice to achieve the brilliant white of final refined sugar. Milk of lime is added to neutralize the acidity of the juice, a critical step for preventing sucrose inversion. Automated sensors monitor pH levels constantly, ensuring chemical stability throughout the process. The juice is now heated to over 105 degrees Celsius to accelerate the clarification process and eliminate bacteria-precise temperature. Control is vital for the upcoming decantation stage, where impurities will be separated by gravity. The flash tank removes dissolved gases, preventing air bubbles from interfering with the settling of impurities. Flocculants are added to bind small particles together, creating larger flocks that will sink rapidly in the decanters. Hot syrup is stored in insulated buffer tanks, maintaining temperature and density before the critical crystallization phase. Real-time Brix monitoring ensures the syrup has reached the exact concentration needed for crystal growth. Secondary syrup clarification uses dissolved air flotation to remove the last microscopic particles. The separated impurities are removed, leaving a pristine syrup for the final refining steps. Final filtration through microporous screens removes any remaining trace of particulates, ensuring absolute clarity before entering the pans. The syrup is reheated to precise temperatures to ensure optimal solubility. Immense vacuum systems create the negative pressure necessary for low-temperature boiling. In the upcoming stages, concentrated, purified, and ready, the syrup now moves to the crystallization pans to become solid sugar. Syrup is drawn into the pan under deep vacuum, initiating the first stage of the batch boiling process. The seeding process introduces millions of tiny crystals, providing the foundations for the sugar to grow. Inside the pan, the crystals grow rapidly, drawing sugar out of the surrounding liquid. Microscopes ensure each crystal is growing perfectly, without deformities or unwanted clusters. The pan man uses manual samples to confirm the automated data, ensuring a perfect batch every time. Mechanical agitators keep the dense mask heat moving, preventing hot spots and ensuring uniform crystal size. Advanced distributed control systems monitor every variable, ensuring the perfect strike as the crystals reach their target size. In the final minutes, the strike is tightened, reducing the liquid content to maximize the yield of solid crystals. The vacuum is broken, equalizing the pressure, so the massive batch can be discharged from the bottom. The strike is discharged. This 50-ton batch of sugar and syrup is now ready for controlled cooling. The massacquit is collected in receivers before being moved to horizontal crystallizers for further refinement. In these vessels, the massacquit is cooled slowly. This exhausts the molasses, forcing more sugar onto the existing crystals. Cooling must be precisely controlled. Cooling too fast would create unwanted fine grain, while too slow would hurt efficiency. A final check confirms the crystals are uniform and ready for the centrifuge. The crystallization process is complete. Now we must separate the solid sugar from the liquid molasses. Welcome to the separation station, where centrifugal force will strip the molasses from the sugar crystals at over 1,000 RPM. Each batch is carefully measured. Too much material would unbalance the basket, while too little would reduce efficiency. Centrifugal force, thousands of times stronger than gravity, forces the liquid molasses through the mesh while retaining the solid crystals. A precisely timed wash with hot water and steam removes the final film of molasses, leaving only pure white sugar. The molasses is separated forever, directed to separate storage for secondary industrial uses. The separation is complete, pure. Moist white sugar crystals are discharged, ready for final drying. The moist sugar is moved via vibratory conveyors to prevent crystal damage, while maintaining a steady flow. Centrifugal cyclones recover fine sugar particles from the exhaust air, ensuring zero waste and a clean environment. Internal distributors ensure even weight distribution, preventing structural stress on the silo walls. final high-intensity magnetic trap ensures absolute product safety before the sugar reaches the packaging units. Automated bagging. Lines process thousands of units per hour, maintaining strict weight accuracy to within a few grams. Millions of tons of sugar are staged here, ready to be shipped to markets across the globe. Millions of tons processed with precision. This is the giant technology behind the sugar in your world.